Hey everyone, my name's Zach. I'm a PM here at ClickHouse. I own our internal SQL interface and also our kind of cloud console as well. And today I'm going to talk to you a little bit about an internal project of ours focused on observability and product analytics, forensics, logging, and a lot of other things. Because it encompasses this kind of wide range of different solutions, Danny over here actually decided that we should call it Galaxy. So if you wondered where the nebulous name Galaxy came from, that's where. No, you move away from Redshift to Galaxy. You'll hear more on that later tonight. Cool. Anyhow, before we dive into exactly kind of what Galaxy has become, I want to back up a second and kind of explain how we got here. So before joining ClickHouse, I worked for a small company called Archetype, and we built a interface for relational databases, MySQL, Postgres, Cockroach, SQLite, ClickHouse included. And while I was at Archetype, one thing we struggled with was gathering product analytics, understanding where users were encountering pain, understanding why users were or weren't activating, all kinds of different questions. And so an early question we had was, how can we instrument product analytics within our application and understand, what our users are actually doing and understand how we can improve the application. We looked at a variety of different solutions, Mixpanel included, Amplitude, all of these different solutions, and we determined that none of them were really A, flexible enough, and B, cheap enough to justify using at such an early stage in our company. And given that we were building a database visualization tool, we figured we could just kind of build our own and then dog food our own product to actually improve it and use it. So this is kind of like a screenshot of an early version of our kind of telemetry solution that we implemented in Archetype. You can see it's like fairly simple. It's got, 10-ish columns. We've got like a JSON payload column. We've got a couple of other ones, environment, client version, event name, and some other information as well. And we initially stood this up in RDS and MySQL, and away we went. Here's kind of just like a basic overview of like what exactly we set up. Basically, it was super primitive on our marketing side and in our application itself. We kind of, we defined a function that would basically send events into the database. Yeah, pretty self-explanatory. Then on top of that initial events table where we sent the events, we built a bunch of views that we'd periodically refresh. They weren't materialized because they kind of required some more complicated upserts and stuff like that. For example, a user may in one time frame be created but not activated. We'd have to kind of go back and iteratively check to make sure that that user, whenever we refreshed it, had they activated or not. Same thing with user activity. That was kind of just like a ledger of which users were active which days and in which states they were. And then we kind of used those two views to generate like a daily stats table as well, which was kind of like our top level view of what exactly, how our app was performing, what was being used, how everything was working. Were there any problems? So basically, this ended up being like an ongoing kind of pet project of ours. We were obsessively kind of trying to improve it all the time. And it really actually translated into meaningful results for us, like a 6-person startup. We didn't have time to have like a product analytics person. We didn't have time to hire like a, data team to optimize a lot of this stuff. So really, we kind of just had a couple of guys trying to, basically ask questions in SQL and get answers from our events table. So I guess the best way to describe this is we basically had three different avenues for exploring this data. One was top of funnel analytics. Basically, in this case, we took a lot of data from our marketing site events that we were generating and determined things like conversions to download from blog posts, from ad campaigns we ran on Google, from product launches. So, we launched on Product Hunt, we launched on Hacker News. We could track exactly how many of those kind of clicks turned into downloads. and follow those users through the funnel. This also enabled us, especially at an early stage, it was super valuable. It enabled us to actually calculate like almost exact per user CACs based on the cost it took to produce blog content, the cost it took to pay for an ad campaign. This was all super, super useful to us. And, we'd speak with like people trying to sell us ad space and stuff like that. And they'd be like, well, do you have any sense of what your CAC is? We'd explain it to them. They'd be like, we've never talked to anybody who's, got like an actual dollar figure at your stage. So it's super cool. As a result, in this vertical, we managed to kind of optimize the kind of content that we were paying to create. And we reduced the cost, like the cost of customer acquisition from blog posts by 30%. We also managed to kind of, by tweaking ad campaigns and tweaking kind of content strategy, we managed to grow our like site monthly unique visitors from 6,000 to 40,000 in about 10 months, which is super, super cool. Second vertical, product KPI tracking. This is, for me, what was kind of probably the most interesting one. Basically, we wanted to understand what users, where they were experiencing pain, where they were getting the light bulb moment, what were like North Star metrics for user success. All of these things can be very easily kind of measured using, kind of holistic event-driven analytics. So in our app, every time you click a button, every time you kind of interacted with the app, we would generate an event record. And we could kind of tell in order how users were actually going through and, adding their first data source, running their first query, generating their first chart. All these things were super, super easy to kind of determine from the data. This helped us kind of first define and then refine our activation and retention definitions, which helped us to kind of shape goals and also ultimately increase our activation and retention rates substantially. 3x for activation, 2.5x for retention. Everett over there, who now works at Vantage, remembers just how abrupt the change was when we went from like around 20% activation rate to like, 70? Just a couple of months. Same thing with retention. We realized that, after 2 weeks, a lot of users were churning. Couldn't figure out, why. We started to look into, what it was that these users were hitting or they weren't hitting, right? And then we adjusted kind of the product in order to, better fit their needs. On top of this, we also managed to measure like kind of more top level KPIs like daily active users, weekly active users, monthly active users, feature adoption. So if we shipped a new feature, how many people actually found it? Do we need to change how it's surfaced? Do we need to kind of call it out more? All these different things. It was super, super useful. And we rolled all of that up daily into an automated report that would get sent to our inboxes at like 7 p.m. every day. So we knew exactly every single day how many users had actually used Archetype that day, how many users had signed up. If we were looking at specific features, we could look at that as well. And this was just super useful. Instead of having to kind of wait until something went wrong, we knew every single evening, right, if we needed to kind of flag something for the next day. Finally, for our engineers, we also instrumented events around performance monitoring and application stability related kind of heuristics. So basically, we instrumented a bunch of, whenever a user hit an error in the app, we'd record a client error event and then attach a bunch of relevant information, error message, et cetera, in the payload. We also started attaching different metrics around like memory usage, like system resource usage in payloads for like a wide range of different events. Kind of results-wise, whenever users encountered bugs and would report them to us, it was very easy to look up, okay, this is exactly what happened leading up to when they hit an error, right? We can tell they hit this error after clicking on a specific, button in a specific modal. Easy, right? Once you can reproduce it easily, it's much easier to triage and, push a fix. So we could turn around fixes super, super quickly because again, without even having to like watch a full story or a highlight or anything like that, we could just look at the event records. Second of all, when we were trying to optimize stability and performance in particular, we were running on Electron. And if anybody has any experience with Electron development, you know that it's super heavy, super imperformant. It's all around, I wouldn't recommend actually developing anything on Electron. So, lesson learned. That being said, we were already a little too far gone. And we needed to figure out a way to use less memory and make sure that, over time, performance didn't degrade if you left the app open too long. right? Are there any memory leaks? Any things like that. So periodically, with some events, we'd ship a value in the payload that explained what the actual memory usage of the application was. And so we could determine after like a user encountered a certain behavior, did the memory usage go up and then not go back down again? Is there a memory leak? You know, what's going on? So for all these reasons, we actually managed to improve our the performance of our app drastically. Actually, this became a huge sticking point during the acquisition process with ClickHouse. Alexi, the founder of ClickHouse, when we were demoing it to him, kept asking, okay, well, is it going to break if we try to stream down 1 billion rows? Answer was no, actually, it held up. We weren't really totally sure at the time. Anyhow, hopefully this is kind of a basic overview of like why it is that this kind of stuff is super important, and you know why maybe some of these kind of like you know turnkey solutions may not actually be right. They don't give you flexibility. They're probably expensive. They're sometimes opinionated in the wrong way even, and they kind of don't necessarily give you everything you need. You can develop it yourself. So I think this takes us to kind of the downsides of what we developed. First and foremost, we didn't really kind of go in with a cohesive plan for event naming conventions and stuff like that. So we ended up with like a hodgepodge of like camel case, snake case, predicate first, predicate last, right? And it became very difficult as you know we tried to kind of expand usage of this telemetry table to additional users. It became very, very difficult to explain to them why events were named as such, and they couldn't figure out like if they were trying to find something themselves, it was very difficult to figure out exactly what the naming convention was for a specific event. It really kind of depended on when it was instrumented. Second of all, it was built on MySQL. We're at a ClickHouse meetup, so everybody here is kind of used to data at scale. At the time, we weren't really, right? So we had these like super, I guess what you'd call stupid queries running to you know rebuild these views every so often. And at first, the performance was tolerable. You know, when we had fewer users, it took maybe 2 minutes to rebuild the view. And that was fine. It was kind of annoying, but it was fine. By the end, right before the acquisition, we had, I think, about 45 million records in the table, which is not that many for ClickHouse, right? But for like just a vanilla RDS instance, it was a lot. The same views took 90 minutes to build. So you couldn't answer any questions for 90 minutes. It was pretty abysmal, and we were basically ready to throw in the towel at that point, just given the performance. You know, I tried everything to try to optimize these queries and make them, you know, simpler and more performant. But even with optimization, we just couldn't bring the time down any further. Third of all, we had this kind of desire to actually instrument server-side events and kind of other sources of event data into our database. But our initial schema really wasn't future-proof at all. And as anybody here probably knows, running migrations is like a pain, right? Especially on RDS MySQL. You know, if we had to do it all over again and we were going to use MySQL, I think we'd use something like PlanetScale. But anyhow, don't think you use anything MySQL based at all. That brings us to, I guess, about October 2022, when the acquisition with ClickHouse was finalized. We began rewriting the entire archetype app as a fully like cloud native web application that would sit inside of ClickHouse's cloud product. And we discussed whether we wanted to re-implement this event kind of analytics architecture. And initially, given these slow queries, non-future-proof schema, and kind of annoying naming conventions or lack of naming conventions, we were kind of almost ready to throw in the towel and say, you know what, we'll move on. Nobody's requiring this of us. But then I guess we had we were kind of curious, how is performance going to be different in ClickHouse? So we went ahead and just migrated all of our archetype analytics data, all like 47 million rows at that point, over into ClickHouse, and kind of recreated the same kind of view generation queries in ClickHouse, and they executed in under a second every time. It was that much faster. And so that got us thinking, okay, well, maybe this isn't actually a lost cause. So we went back and we kind of redesigned the schema a little bit. And we wanted to kind of make it a little bit more future-proof, but it basically resembled what we had kind of initially set up in the first place. And we started collecting event data almost immediately. Now, at this point, I guess we were actually at the last meetup in the Rocked offices. And right before my last presentation here, I was demoing to Danny and Guy what we'd kind of set up with these analytics for the SQL console. And they wanted it in the rest of the control plane stack. So that's how Galaxy was really born. But we kind of started all over again to make it really deliberately completely future-proof, and also to support like a wide range of other sources of data and also destinations for data as well. So here's basically the improvements that I think we came up with over time for Galaxy. First of all, obviously a future-proof schema design. We kind of kept our naming convention for fields fairly generic. Instead of kind of calling something a component, we call it a namespace. That way it fits for server-side events as well. It doesn't just fit for kind of UI level user events. We went through and created an entire spreadsheet where we planned out what every single event should be named, so that we could have a consistent naming convention. We put the verbs last every single time now. It's all snake case, and many other kind of rules around naming conventions. Third of all, because we knew that there were going to be more consumers for this data, and we wanted to report more data than before, we leveraged materialized views in order to kind of provide restricted access to different kind of internal consumers. So for example, if you are like on the marketing team and you need just like kind of top level product analytics, we don't want to give you access to forensic level logging. Well, probably not anyhow. Similarly, somebody on the engineering team who's kind of doing like a fraud investigation or a forensics investigation definitely does need that access, right? So for security and compliance reasons, we kind of use these materialized views in order to make sure that that access is restricted to those for whom it is necessary. Fourth of all, we set up we abstracted like a completely new interface, which is actually what we call Galaxy, to kind of catch all of the requests and send them onto their final destination. In some cases, this isn't just our ClickHouse instance at the other end. It is Segment and kind of any other potential future destination moving forward. It's very, very flexible. Finally, we've kind of implemented now server-side events for real. We've got forensics, logging, and tracing. It's very rudimentary, nothing like our forensic Chronosphere are doing. And then finally, we actually switched to a better DBMS, obviously. Clickstream Data Warehouse, that's what ClickHouse is actually called. Makes sense, right? Take in large amounts of data, aggregate it really quickly. Makes sense. So here is like an updated kind of architecture overview of what Galaxy now looks like. So basically, we've got three sources currently. One is called the Cloud Console. We call it internally the control plane. One is our SQL console. That's kind of where users can interact with their ClickHouse service without using like the CLI or a different database client. And finally, we've got the marketing side as well. All of these different places send events to Galaxy, which then routes them onward to either the base table or to the base table and Segment right now as well, and any other future places. Finally, as we mentioned, we've got all these materialized views on top of it to kind of make it easy to restrict access and basically also separate it out. So for example, if you're just trying to look for stuff on the dev environment, it's very easy already. You don't have to even filter by that field, and we don't have to include it in the sort key. Things like that. So for now, I actually don't want to kind of do any more slides. I actually want to just show you roughly what it is we've come up with, if that's okay. So here is actually live what the kind of end result looks like at forensics level in ClickHouse. So we've got here prod forensics. It's got 964 million records right now. For reference, we turned this on a month ago. So that's we're kind of at about 1 billion records a month. And as you can see, we've got all these different fields across, and kind of depending upon what kind of event it is, some of these fields may be null, some of them may be used, some of them may not be used. One thing that's consistent is we've got this kind of unstructured payload. We have it as a string, which then we convert to JSON whenever we actually want to query something from within it. Given ClickHouse's JSON support, I think that was the only way to do it. So here's kind of some examples of things that we can actually do using Galaxy. Here's like a query that we use for weekly stats for the SQL console in particular. As you can see, it's super, super quick. And we can get very easily kind of product level KPIs, such as like how many queries were actually run in a given week, how many people open tables, what the total usage time was for all of our users, average usage time, breakdown of new versus existing users, all these kinds of cool things. Another one is, this is just kind of like almost a vanity metric, total number of queries run from the SQL console. We hit 100,000 a few weeks ago. By the way, we turned this on in December, so it's all fairly new. Finally, kind of for our engineers, we can also do things around kind of like server-side logging. So for example, here's a much more kind of complicated query that lets us kind of explore things like API requests and responses that we receive. And so this is super useful for kind of things like performance monitoring. If we think something's going wrong with an API, or if it's super, super slow, we can very easily drill down and figure out like, when the average response time was 500 milliseconds and we're expecting like 80, what was going on? Was the volume super high, something super overloaded on the other end, et cetera? Now, the cool thing is you can take this data from ClickHouse Cloud, for example, and pipe it into something like Grafana. So here's like just like a basic dashboard I've set up today to kind of demo like how exactly this might look, for kind of like a internal consumer who is trying to actually look at things like API requests and kind of examining where things may have gone wrong. So here we've got like a table that's got like a list of all, kind of like a summary of all API requests. But if we drill down into one, so for example, query metrics, this will hopefully reload there. Perfect. And now we can see like, where, over time, basically, what the volume of requests was. We can see like an actual log of all the requests here. And we can also kind of see things like how, what the response times look like. So if there are any like outliers, right, we can kind of drill down and figure out like what was going on. Is the user just super far away? What's the deal? And you can do really cool things, especially with kind of visualization tools like this. Like, so if we wanted to zoom in specifically on this area, right, it's super simple, and the query will regenerate. So finally, just one other cool thing. We can also, using like an IP tree dictionary that is hooked up to like an open source like geolocation set, we can look at things like where all these API requests are actually coming from over a specific time. So for example, if we wanted to look at like the last 30 days, and this will take a second because it's a lot of data points. We can now see exactly kind of where people are sending API requests from. So cool. This is a basic overview of Galaxy. Thanks so much. Any questions?
Sitting in the cloud, or sitting in a local server somewhere.
This is on the cloud. This is all live. Yeah, sorry. This is all live. This is production data.
So the backup is sitting in the cloud. Is a way to back up all this incredible amount of data that you guys have.
Sorry.
The backup. Do you have a replication way to do the backup? Or?
Yeah, so ClickHouse Cloud, by default, we provision 3 nodes in a cluster. So it's replicated thrice. Additionally, we schedule a backup. I think it's every 24 hours right now. Yeah, if there's any changes, we back it up every 24 hours. You can restore those backups. We're also working on, supposedly, allowing you to export those backups to your own S3 bucket just in case.
Thanks for the cool talk. I'm curious about the data ingestion. Do you guys use any kind of message brokers, or you insert it directly to the ClickHouse?
So we have an interface that we've abstracted in front of it that we call Galaxy, right? That has kind of interesting features like rate limiting and stuff like that. But I think we basically just use the HTTP endpoint at the end of the day that ClickHouse exposes, right? So we're just sending it over HTTP. Actually, the architect of Galaxy is sitting right here. So I'm going to pass the mic to him.
Not directly the architect of the ingestion piece, but if I'm not mistaken, right now we're at a scale where we don't need any fancy forward layer. But in the future, there's definitely a possibility that we'll add some type of ingestion mechanism to help us deal with larger scales. So far, we didn't need it. But actually, I also have a question. So if that works, what are some interesting decisions that came out of this kind of data? So like, how did you actually use it?
That's a great question. So please don't kill me, Tanya. We were struggling to reconcile with what appeared to be very low activation rate and like kind of user success when they signed in for the first time for a while. But then what we realized with Galaxy was that the numbers were kind of playing tricks on us, right? What we were kind of seeing through other analytical data sources was just like a, number, right? And it looked low. And it looked low every single week, week after week. Using Galaxy, we kind of managed to identify some kind of common trends amongst these users that weren't activating. And we realized that a lot of them weren't activating because they couldn't activate because their country was blocked, right? Or because they'd signed up through a different part of our kind of like stack and they weren't actually trying to create a service. They were just trying to use the learning management system, right? But according to the data that we had before Galaxy, they were just unactivated users. Things like this, like solving them were super helpful. All of a sudden, our activation rate looked really healthy. Any more questions?
This is a very non-technical question, so I apologize from a more PR end of things here. Do I have it right that it sounds like you made what would become Galaxy in-house originally as a, that was not your core product, but that's kind of what later on would become the vehicle for the acquisition?
So it was not our core product and it was not a vehicle for our acquisition. It was just a tool that we developed that helped us very rapidly improve things like activation, retention, understand what our users were actually doing. It kind of informed our product direction. So I guess indirectly, well, actually very directly, it did lead to the acquisition eventually, right? It helped us tweak the app and make it really performant. It helped us figure out what features to build. It helped us, well, yeah, basically do everything. So it wasn't what ClickHouse I think bought us for. They bought us for the interface that we built. But the data and the way we collected it was super helpful in getting there.
Gotcha. Thank you.
That's a good question. So we are a platform, not a solution at ClickHouse Cloud, but it wouldn't be very difficult to set something like this up. In fact, given kind of the HTTP interface that ClickHouse exposes by default, you can very easily just start sending data into a table and, kind of building kind of visualizations or dashboards on top of it. Cool. Thanks guys so much.